Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on implementing InterVLAN routing. So let's go ahead and read our objective for this lab. It says InterVLAN routing is the process of forwarding traffic from a device that resides on one VLAN to a device that resides in another. Without InterVLAN routing, a device can communicate with only other devices that reside in the same VLAN. Therefore, configuring devices to reside in a VLAN is similar to physically connecting devices to a single unmanaged switch or hub without a router. In this lab, you will implement InterVLAN routing so that devices that are configured to operate in VLAN 10, VLAN 20, and VLAN 30 can communicate with each other. So we can look at our lab topology that we're working with this lab. As you can see, we have a router that's connected up at the top of our topology. Then we have a switch 1, a switch 2, and a switch 3. We can see that switch 1 supports VLANs 200 and 300. We can see that switch 2 supports VLAN 100, and switch 3 supports VLAN 100 and also VLAN 300. So we're going to have to implement InterVLAN routing between these switches so that other PCs PCs within one VLAN can communicate with PCs in other VLANs. So we're going to have a trunk between these switches as well. All right. So let's look at the commands that we're going to be using for this lab. We have configure terminal, which enters global configuration mode from privileged exec mode. We have description string, string description of interface configuration. We have enable, which enters privileged exec mode. We have end, which ends in exits configuration mode. We have encapsulation.1q VLAN ID. It configures a router interface to use 802.1q encapsulation for a specified VLAN ID. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have interface type number sub interface ID, which creates a sub interface. We have IP address subnet mask, which assigns an IP address and subnet mask to an interface. We have IP config / default gateway IP address. This is used in NetSim to assign a default gateway IP address to a workstation interface. We have IP config / IP address subnet mask, which is used in NetSim to assign an IP address and subnet mask to a workstation interface. We have ping IP address, which sends an ICP echo request to the specified address. We have show interfaces trunk, which displays port and interface trunk information. We have show IP interface brief, which displays a brief summary of interface status and configuration. We have show VLAN, which displays VLAN information, and we have no shutdown, which enables an interface. All right, so these are all of the commands and descriptions that are going to be used within this lab. Next, we have our IP address information. We can see that router 1, let me move the topology up here in the top left. We can see that router 1 has 3 sub interfaces, which are in the within the Fast Ethernet 1.0 interface. As you can see, we have .100, .200, and .300, and they all have different IP addresses. All right, so you can see that we have a slash. We have a not a slash. We have a .240 subnet mask for each of these sub interfaces. We can see that switch 1 has a VLAN 100, 200, and 300 interface. They all have their IP address information right here. Same thing for switch 2. It has VLAN 100, 200, and 300 SVI interfaces configured with IP address information. And then switch 3 as well has all of the VLANs that we previously mentioned, 100, 200, and 300. And it has its SVI IP address and SVI IP addresses within this IP address chart. Okay, so we can see the different host IP addresses within this table as well. So this is good information to have as we go along inside of this lab. We can refer back to this table if we need help with anything. Okay, So let's go ahead and get into our lab task for this lab. I'm going to keep my topology up here in the top left. We're going to be doing our lab readings in the top right, and we're going to be doing our configuration down here at the bottom as normal. Let me adjust my camera so you guys can see the CLI a little bit better. I may need to back up the camera just a tad bit so you guys can see the questions too. About right there, I think is where I'm going to keep the camera. All right, cool. All right, task number 1, it says configure VLAN connectivity. All right, it says in this task you will learn, in this task you will examine the VLANs that are already configured on the network and configure connectivity for the devices on each VLAN. All right, so right here it says on switch 1, issue the commands to display information about the VLANs configured on the switch. What non-default VLANs are configured? Which switch ports are configured to operate on which non-default VLANs? All right, so let's do a enable. Let's do a show VLAN. Let's do a show VLAN. And this was supposed to be on, okay, I'm on, sorry, I'm on the wrong device. It says switch 1. I wonder why I didn't get any output. Yeah, and I was on a router. I don't know why I did that. All right, show VLANs. All right, cool. All right, so we can see that our non-default VLANs are VLANs 100, 200, and 300. As you can see, they have different department markings. VLAN 100 looks to be sales, VLAN 200 looks to be marketing, and VLAN 300 looks to be the developers. We can see the ports that are connected off of each VLAN. We can see that switch 1 has a the Fast Ethernet 01 port is connected to VLAN 200, as we can see from my topology, and is a developer off of VLAN 300 on switch 1 as well. All right, so those are the non-default VLANs, and I also just pointed out the ports that are connected to non-default VLANs as well. All right, so it says on switch 2, issue the command to display information about the VLANs configured on the switch. What non-default VLANs are configured? Which switch ports are configured to operate on which non-default VLAN? So if we go to switch 2, let's do the same command over here. Let's do an enable. Let's show a show VLAN. All right, and we can see that it also has the VLAN 100, 200, and 300 VLANs. And we can see that switch 2 only has a port, which is the Fast Ethernet 03, that's connected down to VLAN 100, which is it's a sales PC. Okay. All right. So lastly, it says on switch 3, issue the command to display information about the VLANs configured on the switch. Which non-default VLANs are configured? Which switch ports are configured to operate in which non-default VLANs? Let's pull up switch 3 now. Give a mirror CLI output. Let's do a show VLAN. All right, we can see that VLAN 3 also has VLAN 100, 200, and 300. It has a PC within the sales VLAN, VLAN 100, and it also has a PC within the development part of the company as well, which is VLAN 300, the Fast Ethernet 05 connection right here. All right. So number 4, it says on switch 1, switch 2, and switch 3, issue the commands to display summary information about interfaces configured on the switch. In what state are the ports that are assigned to VLANs? Has each switch been configured with VLAN interfaces? So let's go to switch 1 first. Let's do a show IP interface brief. All right. So we can see that it does not have any. The question was, in what state are the ports that are assigned to VLANs? Okay. So the ports that are assigned to VLANs look to be in the up state. Right. So that is the Fast Ethernet 01, which we can see right here, and the Fast Ethernet 02 is also in the up state. All right. And we can see that those are the ones that are configured on switch 1 right here. All right. It says, has each switch been configured with VLAN interfaces? All right, so let's go to switch 2. Let's do the same command. Let's do a show IP interface brief. All right, so you can see that its Fast Ethernet 03 connection is up right here in the output. So that looks good. And lastly, let's do the same thing on switch 3. Let's do a show IP interface brief. All right, this one had one in the Fast Ethernet 04 and also 05. So 04 and 05 are both in the up state. All right. And let's see what Boson says about the last output. It says you can also notice that the Fast Ethernet 010 port on switch 1 and the Fast Ethernet 010 and 011 ports on switch 2 and the Fast Ethernet 011 port on switch 3 are also in the up state. These ports connect the switches to each other and therefore trunk ports. As such, they have not been assigned to a specific VLAN. All right. And then also up here it says based on the output, you can determine that the interfaces listed as assigned to VLANs on each switch are in the up state. However, no non-default VLAN interfaces are configured on the switches. VLAN interfaces, which are virtual interfaces, are layer 3 interfaces that can be configured with IP addresses. When configured with a layer 3 address, VLAN interfaces can be used as a default gateway or enable the switch to remotely manage from other devices that are connected to the same VLAN as VLAN interfaces. All right, so that's good information to know. And we know that there's no non-default VLANs configured because we would see that within the show IP interface brief command. All right, so good information to know. All right, right here it says on switch 1, switch 2, and switch 3, issue the command to display information about trunk interfaces. What is the purpose of a trunk port? How do trunk ports differ from access ports? So to answer the first part of that question, the purpose of trunk ports is to carry different traffic from different VLANs over a single interface, basically. So it's from a switch to another switch. If you want different VLANs to be able to talk between the switches, you have to configure a trunk port, and a trunk port allows us to carry different VLANs over this trunk port. All right. An access port is only going to allow one VLAN on that port. And that's going to be the VLAN that's configured on that port. All right, so let's see what Boson is going to say. Well, first let's do the output of the command. Let's do a show interfaces trunk on our switches. Let's do a show interfaces trunk. All right, so we can see that the Fast Ethernet 010 port is trunking on switch 1. I'm just using 802.1q encapsulation. It is trunking, and the native VLAN is 1. You can see the allowed VLANs on the trunk, and some more information about VLANs, the allowed and active and management domain. It's basically the VLANs that are configured on the device. All right, so let's do the same command on each switch. Let's do a show interfaces trunk, and they all should have similar outputs. Yes, as we can see, the Fast Ethernet 010 and 011 ports on switch 2 are trunking. All right. And lastly, we can do on switch 3, let's do a show interface trunk. And similar output here, the Fast Ethernet 011 port on switch 3 is trunking. All right. So let's see what it's going to say about the difference between access ports and trunk ports. I kind of explained it. It says right here, unlike access ports, which typically connect endpoints to switches and operate on a single VLAN, trunk ports allow switches to carry traffic from multiple VLANs across physical switches. Therefore, a VLAN 10 connected to switch 1 can communicate with a VLAN 10 device supported to switch 3 because of trunk ports. The trunk ports in this scenario use the Institute of Electrical and Electronic Engineers 802.1q standard, which works by using VLAN tagging. When traffic that is destined for a specific VLAN is transmitted between switches, the trunk tags the traffic with the appropriate VLAN ID. All right? So yes, that is correct. So number 6, it says on switch 1, switch 2, and switch 3, configure a VLAN interface with each non-default VLAN on the switch. Use the IP address table to appropriately assign an IP address and subnet mask to each VLAN interface. What do you notice about the states of the interfaces as you configure them? All right, so let's start on switch 1. Switch 1. Let's do a configure terminal. Let's go into interface VLAN 100. All right, and let's pull up our IP address table. So switch 1 is supposed to have an IP address of 198.51.100.2. All right, let's go ahead and give that IP address 198.51.100.2. Let's do it 255.255.255.240 subnet mask. Let's do a no shut. All right, let's do an exit. Let's do the same thing for interface VLAN 200. We're gonna look at this IP address. I'm gonna highlight it. 198.51.100.18. Let's go ahead and type that in. IP address 198.51.100.18. 255.255.255.240 subnet mask. All right, let's give an exit. Let's do interface VLAN 300. Lastly, on switch 1, it's IP address 198.51.100.34. So let's go ahead and give that IP address 198.51.100.34. Oops, .34. 255.255.255.240. Let's give an exit and let's do a do show IP interface brief just to confirm everything. And everything looks to be configured correctly. All right. So that looks good. Let's go ahead and move over to switch 2. And let's give the IP address information needed over here. Let's go with configure terminal. On switch 2, we can see the VLAN 100 interface, IP address 198.51.100.3. Let's go ahead and give an interface VLAN 100. Let's do IP address 198.51.100.3, 255.255.255.240. Let's do an exit. Interface VLAN 200 next. Its IP address 198.51.100.19. Let's go ahead and put that in. IP address 198.51.100.19, 255.255.255.240. Let's give an exit. It's going to interface VLAN 300. Its IP address 198.51.100.35. Let's put that in. IP address 198.51.100.35. 255.255.255.240. All right, hit exit. Let's do a do show IP interface brief to confirm. And all of those match up for switch 2, which looks good. Let's lastly do the last one on switch 3. Let's do a configure terminal. Let's go to interface VLAN 100. All right. And its IP address is 198.51.100.4. Let's put that in. IP address 198.51.100.4, 255.255.255.240. Exit. Interface VLAN 200, 198.51.100.20, as we can see right there. Let's type that in. IP address 198.51.100.20, 255.255.255.240. Okay, let's give an exit. Let's go into interface VLAN 300. All right, and its IP address is 198.51.100.36. IP address 198.51.100.36, 255.255.255.240. Exit. Let's do a do show IP interface brief. And all of these addresses match up as well. So we're looking good. All right, now, it said, what do you notice about the states of the interfaces as you configure them? Now let's read what Boson is going to say. It says that, for example, on switch 1, the ports that are connected to host 1 and host 2 operate in VLAN 100 and VLAN 300, both of which contain physical ports that are in the up state on the switch. Therefore, the first rule indicates that the VLAN 100 interface and VLAN 300 interface can transition to and remain in the upstate. However, because of the second rule, the last VLAN interface you curate, which is VLAN 300, is the one that transitions and remains at the upstate. All right, so that makes sense. All right, so it says on host 1, host 2, and host 3, host 4, and host 5, configure the appropriate IP address, subnet mask, and default gateway based on the information in the IP address table. All right, so let's pull up each of these hosts. So host 1, host 2, 3, 4, and 5. All right, so starting on host 1, which is our PC, we can see, let's scroll down in our IP address table. We can see its IP address, subnet mask, and default gateway. All right, so let's do an IP config /IP. Let's give it an IP address of 198.51.100.24. Subnet mask of a 255.255.255.240. All right, let's do an IP config / default gateway of 51.100.100.17. All right, and let's do an IP config /all to confirm the IP address, which is a .24, yes, and our default gateway, which is a .17. Looks good. Let's move on to host 2. Give the IP address information needed for host 2. Let's do an IP config /IP of address of a 198.51.100.38. Let's do a 255.255.255.240 subnet mask. Let's do an IP config /default gateway of 198.51.100.33. Get the enter there. Let's do an IP config /all and .38 for IP address, yes, and .33 for the default gateway. Looks good. Let's move on to host 3. Let's do an IP config /IP. Let's highlight its IP address information. 198.51.100.11. 255.255.255, .240. Let's do an IP config /default gateway, 198.51.100.1. All right, looks good. IP config /all. All right, it has the .11, which looks good, and the .1 for its default gateway. Let's move on to host 4. Let's do an IP config /IP. Let's put this IP address, which is 198.51.100.12. 198.51.100.12. 255.255.255.240. All right, let's do an IP config /default gateway of 198.51.100.1. All right, let's do an IP config /all to confirm a .12 and .1 for default gateway. Looks good. And lastly, on host 5, let's do an IP config /IP of 198.51. Let me highlight it. 198.51.100.39. 255.255.255.240. Enter there. IP config /default gateway of 198.51.100.33. Let's do an IP config /all. You can see its IP address information, 39 and .33 for the default gateway. So it looks good. All right, now it says from host 1, which is 198.51.100.24. So let's go to host 1. Attempt to ping host 2, 198.51.100.138. Host 3, host 4, and host 5. Which ping succeed and which fail, and why? All right, so let's do all of these. Let's do a ping first to 198.51.100.38, which is host 2. and you can see our requests are timing out for host 2. Okay, so we're not able to ping host 2. If we bring up our topology, this is host 1, and this is host 2. And we can see they are in separate VLANs. So that's why those two PCs cannot communicate with each other. We have not set up InterVLAN routing yet. So let's try .100.11, which is host 3. You can see host 3 is in a different VLAN as well, which is VLAN 100. Host 1 is in VLAN 200. So it's not able to ping host 3 either. It's in a different VLAN and also a different subnet. All right, let's try .12. Can we ping .12, which is host 4? It is also in VLAN 100. And as we know, host 1 is in VLAN 200. So these pings are failing as well. They're in different VLANs and also subnets. Let's try host 5, which is .39. And these are going to time out as well because they are in different subnets and also VLANs. And we have not configured InterVLAN routing in this lab yet. All right. So the next one, it says from host 2, ping host 1, host 3, host 4, and host 5. Which pings succeed and which ones fail. So let's go to host 2. And let's do a ping to host 1, which has an IP address of 198.51.100.24. We can see that host 2 is trying to communicate with host 1, which is in different VLANs and subnets. So of course this does not work. This ping is not going to work. The pings to host 3 and host 4 are not going to work either, which are the next two pings because those are in different VLANs and subnets. Let's do .11, which is host 3. This one is not going to succeed either. Okay, so we're trying to ping from host 2, which is in VLAN 300, to host 3, which is in VLAN 100. Those are failing. Let's try to host 4, which is .12. Oops, I put 13. Oh well. Well, I'm not gonna say oh well. I'm gonna make it right. So we wait till these pings time out. Accidentally fat fingered it and put .13. .12. There we go. These are gonna fail too. And then next we have host 5, which will work because they're in the same VLAN. Well, it should work. The trunks are configured correctly. So let's do .39. Oops, 39. Yes, and we are getting replies from host 5. All right. So that looks good. And those are in the same VLAN and also same subnet. All right, now task 2, it says configure InterVLAN routing. In this task, you will configure InterVLAN routing so devices on each VLAN can communicate with devices on other VLANs. All steps in this task should be performed on router 1 unless otherwise specified. Okay, so it says issue the command to create 3 sub-interfaces, one for each of the network's departmental VLANs. On the router's Fast Ethernet 01 interface and enable the interface. Each sub-interface should be identified by the number of the VLAN to which it connects. What purpose do sub-interfaces serve when configuring InterVLAN routing? Well, it gives each VLAN its own virtual connection up to the router. So when the router gets the information, it knows how to, it knows which VLAN is receiving information on, and as a result, it will know how to forward the information as well to the different VLANs within the networks, okay? So let's go to router 1, and let's do a configure terminal, and let's do a, interface fast Ethernet 10.100. All right, we want to do a .200. And we want to do a .300. All right. Now, let's see what Boson's explanation is going to be. It says right here, one benefit of including the VLAN ID as the sub-interface number is a reduction of administrative overhead. Numbering the sub-interfaces the same as the VLAN ID is an easy reminder as to which sub-interface connects to which VLAN, all right? And yes, we are doing a router on a stick configuration because we are doing the sub-interfaces on the router, all right? So we're looking good. Now it says on each sub-interface, configure a description that contains the string connection to VLAN, the VLAN ID, where VLAN ID is the number of the VLAN to which the sub-interface connects. In addition, configure each sub-interface to use IEEE 802.1q encapsulation and to tag traffic for the VLAN on which it should operate. What purpose does configuring a description on the interface serve? When you're looking through, for example, you're running config or even output within the CLI in general, having descriptions can help you troubleshoot and also learn your topology a little bit better. So it's always good to give descriptions so the people that come behind you can figure out what's going on within your configuration and be able to map out the topology from there. All right. So first we're going to do the descriptions. So we need to go into interface Fast Ethernet 100 first. Let's do a description with a connection to VLAN in all caps 100. All right, let's go in. Let's do an exit, and let's go into interface for .200 next. Let's do a description, connection to VLAN 200. All right, let's do an exit, and let's go into interface 300 now. Sub interface Fast Ethernet 10 for the 300 VLAN. Let's do a description, connection to VLAN 300. All right, hit enter. Let's do an exit. All right, now let's go back into .100. Let's do the encapsulation method. You go .100, so this is .100. I need to do an encapsulation .1q for VLAN 100. Let's do an exit. Let's do .200 next. So let's do encapsulation .1q for VLAN 200. Let's do an exit. Let's do .300 next. Encapsulation .1q 300. All right. Now it says right here, on each sub interface, configure the IP address and subnet mask. Refer to the IP addresses table. Each sub interface should be configured with the default gateway, IP address, and VLAN for which it forwards traffic. All right. So let's go to let's look at our IP address information for .100. So we're going to do that interface first. So let's go into .100. Let's do an IP address of 198.51.100.1, 255.255.255.240. All right, let's give an exit. Let's go into .200 next. Do its IP address, which is 198.51.100.17. So let's do a IP address of 198.51.100.17, 255.255.255.240. All right, do an exit. And lastly, let's do .300 sub interface, IP address of 198.51.100.33. Let's do that. 198.51.100.33. 255.255.255.240. Looks good. All right. Now, that should be it. All right. Now it says from host 1, attempt to ping host 2, host 3, host 4, and host 5. Do the ping succeed? Why or why not? So let's go ahead and run back through all of these different pings now. Starting out with ping.100.38, which is host 2. Can we ping? So we're not able to ping. So I want to make sure that I did everything correctly. Let's see. Yeah, InterVLAN routing should work. Let me go to router 1 right quick. Let me do a do show IP interface brief. Okay, so our fast Ethernet 01 interface is in the down state. So let me do this. That's why it's not working. Let me do an exit. Let's go into interface fast Ethernet 10. Let's do a no shut here. All right, now those should come up. Now if I do from host 1, let's try that again. Yes, so now we're able to ping it. That's because my fast Ethernet 01 interface was in the administratively down state. So now all of my pings should work. So .11 should work. Yep, should work. .12 should work as well, which is host 4. And host 5 as well should work because we just configured InterVLAN routing. So .39, which is host 5, is working as well. So that looks to be the end of this lab. So let's go ahead and hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.